Bosch makes a big splash in the hydrogen market, and Plug Power gets a big win in Europe. I'll go over all of this on today's Hydrogen Podcast. So the big questions in the energy industry today are, how is hydrogen the primary driving force behind the evolution of energy? Where is capital being deployed for hydrogen projects globally? And where are the best investment opportunities for early adopters who recognize the importance of hydrogen? I will address the critical issues and give you the information you need to deploy capital. Those are the questions that will unlock the potential of hydrogen, and this podcast will give you the answers. My name is Paul Rodden, and welcome to the Hydrogen Podcast. In a press release on July 13th, into the hydrogen age, Bosch starts volume production of its fuel cell power module. Bosch is entering the hydrogen age of mobility. At its Stuttgart Feuerbach location, the supplier of technology and services has now begun volume production of its fuel cell power module. Nikola Corporation, based in the U.S., will serve as the pilot customer with its Class 8 hydrogen fuel cell truck, which is scheduled to enter the North American market in Q3 of 2023. In a quote from Dr. Stefan Hartung, the chairman of the board of management of Robert Bosch GmbH, said, "Here in the Stuttgart Feuerbach, in the new plant whose history goes back further than any other Bosch plant, the hydrogen future is about to happen." He says, Bosch knows its way around hydrogen and Bosch is growing with hydrogen. The company operates along the entire hydrogen value chain, developing technology for its production and application. By 2030, Bosch plans to generate sales of roughly $5.3 billion with hydrogen technology. In its solutions for the hydrogen economy as well, Bosch is relying on a global manufacturing network and the prowess of its German locations. For example, the Bosch plant in Bamberg, Germany, will supply the Feuerbach factory with the fuel cell stack and important system components such as the electric air compressor and the recirculation blower come from the Bosch plant in Hamburg, Germany. In a quote from Markus Hein, member of the Bosch Board of Management and chairman of Bosch Mobility, Bosch is one of the very few companies that are capable of mass-producing technology as complex as fuel cell stacks. He says, we don't just have the required systems expertise, but also the capability of quickly scaling up new developments to mass production. Production of the fuel cell power module is not only starting in Feuerbach, but also in Chongqing, China. The components it requires will come from the Wuxi plant. Again, according to Hein, Bosch is the first company to produce these systems in both China and Germany. In addition, Bosch is also planning to manufacture stacks for mobile applications in its U.S. plant in Anderson, South Carolina. Worldwide, the company expects that by 2030, 1 in 5 new trucks weighing 6 tons or more will feature a fuel cell powertrain. The press release also says that only with hydrogen can there be a climate-neutral world. For Bosch, that is crystal clear. The company therefore strongly advocates the establishment of a hydrogen economy and is stepping up its investments in hydrogen. Between 2021 and 2026, Bosch will have invested a total of nearly $2.6 billion in the development and manufacturing of its H2 technologies. That is another billion more than was earmarked in the investment plan for 2021 to 2024. The business opportunities for Bosch are huge, as is the effect on jobs. Even now, there are more than 3,000 people at Bosch working on hydrogen technologies, more than half of them in Europe. Most of the vacancies can be filled within the company, and especially with people who have so far worked in Bosch powertrain businesses. However, the further prospects for hydrogen business depend on the political environment. Hartung especially believes that Europe must do much more to create a counterweight to the rapid pace of developments in other regions of the world, such as the United States. More specifically, the Bosch chairman has 4 demands of German and European policymakers. He says, first, we have to step up the pace of hydrogen production in the EU. Second, global supply chains have to be set up. Third, hydrogen has to be used in all sectors of the economy. As a fourth point, he stressed the importance of quickly setting up infrastructure for distributing hydrogen in Europe. At all events, Bosch is ready and applying automotive experience to the hydrogen economy like no other company. This is why the company is also in demand in H2 production. At the start of 2023, Bosch started constructing prototypes for electrolysis using proton exchange membranes. In other words, the reverse of the energy conversion method used in mobile fuel cells. Starting in the fall, the company intends to make 1.25 megawatt prototypes available for pilot applications and is on track to start volume production in in 2025. Bosch is exploring several options for the use of hydrogen. Stationary solid oxide fuel cells can be used for the distributed supply of power and heat. In a pilot project at the hospital in Electrolyzers near Cologne in Germany, Bosch wants to use this technology to achieve overall efficiencies of 90%. The micro power plant there will initially run on natural gas, but can be converted to green hydrogen. Apart from the fuel cell powertrain, Bosch is also working on the hydrogen engine, developing systems for both port and direct injection of hydrogen. The solution is particularly suitable for heavy vehicles on long hauls with especially heavy loads. Again, in a quote from Hein, a hydrogen engine can do everything a diesel engine does, but on top of that, it is carbon neutral. It also allows a fast and cost-effective entry into hydrogen-based mobility. One major advantage is that more than 90% of the development and manufacturing technologies needed for it already exist. The H2 engine is expected to be launched starting in 2024. Even now, Bosch has 4 orders for production projects from all the major economic regions and expects 6-figure unit volumes by 2030. In this field as well, Bosch is dynamically taking the hydrogen economy forward. Okay, so really a massive announcement from Bosch as they enter into the hydrogen economy. Now, I've talked about Bosch previously on the show when they announced that they were going to get into this hydrogen game. No one knew at the time that they were going to put so much of their capital and resources behind this hydrogen venture. But with 3,000 employees currently working in that hydrogen vertical, as well as a projected total investment of $2.6 billion within the next 3 years. That's not an insignificant number considering that for 2022, their total R&D budget was 7.2 billion euros. So their hydrogen R&D investment represents a significant portion of their annual budget and showcases just how serious they are about hydrogen. What I also find interesting is the collaboration with Nikola. Nikola has been discussed several times on this show recently, and that's been for good reason. They've been demonstrating much better decision-making and fiduciary responsibility. So for Bosch to view Nikola as a solid platform to test pilot their new fuel cells speaks volumes as to how Bosch views Nikola's potential in the heavy-duty transport market. I also find it interesting that Bosch is working on hydrogen internal combustion. Everything I've read about the technology points to that application of hydrogen in mobility as the least efficient method. But I know that Cummins and several other internal combustion engine manufacturers are continuing R&D into that application. So it's highly likely that that utilization is more economic than previously thought. And lastly, in a press release from Plug Power, Plug secures 100 megawatt electrolyzer deal for green hydrogen project in Europe. Plug Power, a global leader in comprehensive hydrogen solutions for green hydrogen economy, secured an order for 100 megawatts of proton exchange membrane electrolyzers. This is the largest announced project in the oil and gas sector in Europe. The Plug electrolyzers will be powered by 100% renewable energy and will generate approximately 43 tons of green hydrogen per day to replace gray hydrogen in the oil refining process. This will eliminate approximately 516 tons per day of CO2. In a quote from Andy Marsh, the CEO of Plug Power, Plug is playing a leading role in advancing green hydrogen projects in Europe through the deployment of our industry-leading PEM technology. We are demonstrating how green hydrogen can be generated at scale to decarbonize hard-to-abate industries while also helping companies to achieve aggressive carbon reduction goals. Plug provided engineering support for a front-end engineering and design or FEED study leading to the successful decision to move the project to execution phase. The electrolyzers will be delivered and installed next year. Now, Plug's electrolyzers use a PEM stack technology and a modular design that offers a small footprint with potential for a capacity expansion. The electrolyzer's hydrogen output instantaneously adjusts based on electrical input, which is especially important when paired with intermittent renewable sources. The PEM stacks for the systems will be manufactured at Plug's 155,000 square foot Gigafactory in Rochester, New York. The Gigafactory currently has capacity of 100 megawatts per month of electrolyzer stacks. All right, well, a big congratulations to Plug on this win. And while this press release doesn't mention who has purchased the electrolyzers, we do know that this application is for downstream refining of oil and gas, which has used hydrogen for decades to develop the base products in the oil and gas industry, as well as clean up the sulfur content in sour gas. My guess is that this tech is going to be deployed somewhere in the North Sea, perhaps in the UK in one of their many refineries. That's just a guess, but what is interesting is that in these areas, there's plenty of salt dome storage for CCUS, and I'm curious just how much of the legacy gray hydrogen will be scrapped for electrolytic hydrogen versus retrofitting the legacy facilities to capture and store the hydrogen in these salt domes. Both methods make sense to me, as there is ample renewable energy from offshore wind and fresh water for the electrolyzers, and plenty of storage capacity for CO2 for the SMR process. All right, that's it for me, everyone. If you have a second, I would really appreciate it if you could leave a good review on whatever platform it is that you listen to. Apple Podcasts, Spotify, Google, YouTube, whatever it is. That would be a tremendous help to the show. And as always, if you ever have any feedback, you're welcome to email me directly at info@thehydrogenpodcast.com. So until next time, keep your eyes up and honor one another. Hey, this is Paul. I hope you liked this podcast. If you did and want to hear more, I'd appreciate it if you would either subscribe to this channel on YouTube or connect with your favorite platform through my website at www.thehydrogenpodcast.com. Thanks for listening. I very much appreciate it. Have a great day.